Perfect. Well, thank you for having us, everybody. This is our monthly Stir Shaken No session. And as a quick recap, we're going to go over some recent regulatory and industry news since our last meeting. And then we're going to do a deep dive into a technical topic. And this month's technical topic is one of the most interesting, I think, rich call data. And then we'll open up for questions, discussion at the end. And as a reminder, or for those who don't know, Donald and I are both from TransNexus. TransNexus is a software company, got founded in 1997, and we supply software for telephone service providers. That includes, of course, their Shaken software, but also robocall, TDOS, and telecom fraud prevention. So we are fairly familiar with Shaken, and we hope we can answer any questions that come up after we go through this. And with that, I'm going to hand it over to Donald, who's going to go through the recent regulatory and industry news.
Thank you, Alec. We have a few items that have happened since our last call. The FCC designated the Industry Traceback Group, the ITG, as a traceback consortium, and Neustar was appointed. The PA and the CA in Canada. I just have a little bit of information about each of those for you before we get into rich call data. Some of you may be familiar with the Industry Traceback Group. It was led, the formation of it was led by US Telecom. Now it's grown to have 30 service providers who cooperate and help each other to trace back the source of illegal robocalls. And it's been very successful in doing that. And there have been some news items this year that we've covered. Some of those I think happened when we were recovering these calls, where they trace back some illegal robocall activity. It sent letters to the FTC and FCC, sent out letters and get it stopped. So it's been very effective. The Trace Act requires an official designation of a traceback consortium, which looks a lot like what the ITG does. And so it became official on July 27th that in compliance with the Trace Act, the FCC is designated the ITG. So that's another check on the list of things to do for Stir, Shake, and rollout this year. And the other item that we have is from Canada. Canada has designated Neustar, appointed them as both the PA, the policy administrator, and the CA, the certification authority. So the policy administrators, you may be familiar when we talked about governance. They manage the rules and approval of service providers and certificate authorities and such. So it's a governance role. And the certification authorities, they provide certs, shaken certs that service providers need to attest to calls. So Neustar's wear two hats on this one. And it's just been announced on the 29th of July. And they're scheduled to be ready and up and running with that by end of September of this year. So that's a catch up on the news. And now let's dive into rich call data, a very interesting topic, and I think something that enterprises and businesses will be very interested in. So, to get some value out of Stir, Shake, and I think it'll really help them. So take it away, Alec.
Yeah, thank you, Donald. So we're going to talk about rich call data, but as a quick recap, I just want to remind everybody what the Shaken call flow looks like so that we can show what specifically rich call data has added to it. So the Shaken call flow starts with the calling party making a phone call, whether that calling party be an enterprise or a LTE phone, it doesn't matter. They make a phone call that is sent to the originating telephone service provider. And that originating telephone service provider signs that call using an authentication service, which adds an identity header into the SIP signaling, goes through the SIP network until it reaches the terminating service provider, who sends it up to a verification service to verify that call. And they're verifying that that was signed by somebody they trust, that the calling and called number weren't tampered with in flight, and that the person who signed that call is got a signature on it that has a recent freshness to it. It's recently signed, not something that was signed a month ago and someone's replaying the same identity token. So there's some steps that they do for verification, but it's all about making sure that the calling and called number in the signaling are accurate. Nothing to do with the actual contents of the call, who is specifically placing the call. It's just that the calling and called party numbers aren't being changed. Specifically, here's kind of this example identity header that's been added into the SIP signaling, which is what's cryptographically signed. And when we decode that out, you see the following kind of contents within that, this header, and then the payload. You got the attestation, the destination, origination number, timestamp, and a orig ID, right? So it's all about the calling and called number and kind of your confidence in the calling and called numbers, that attestation. But there's nothing to do with the source of the call or the reason of the call or anything like that, right? It's all about the numbers. And this is where RCD comes in. Rich call data adds additional information to that SIP signaling, specifically within the identity header. So you add a display name, and that's a required field. The rest are optional. You can add a call reason, why you're placing the phone call. You can add a URL that references an image. Maybe it's your headshot, right? If it's a consumer, an individual person making a phone call, or it's a company logo if it's an enterprise or a company making a phone call, whatever makes sense from an image perspective. You can have a URL referencing a website. So more of probably an enterprise use case, but let's say you're calling somebody and you want them to verify that they're home to receive their delivery, and they click a link and can do something, something like that. You could pass some website in there. It remains to be seen exactly how handsets are going to utilize that information, but there could be some interesting use cases. And then, of course, you can pass a JCard or a URL that references a JCard. And a JCard is just a format for storing a contact card in JSON format, right? So it's contact cards, typical fields. You can have an address, an email, birthday, all sorts of information. So it's kind of cool. Instead of getting a phone call and then, oh, let me add that person into my contact list, they can basically be added to your contact list automatically, where you get a phone call and it's already got their picture and all that information. It'd be very, very nice for consumers, but for enterprise, it's going to get even better. And we'll talk a little more about that in a moment. And a key thing to all of this is it's cryptographically secure. It is in the signed identity header. It cannot be tampered with. If you were to tamper with a value in flight, it would break the signature and break shaken verification, and it would be immediately evident to the receiving party, who would not display this information to the handset and may not even accept the call. That's local policy, what they choose to do. And if we look at this rich call data and we look at a call flow, it's really not much different than shaken, right? You've just added RCD support into an authentication service. You've added RCD support into the verification service. And it's done in such a way that it's backwards compatible. A verification service should, by definition, accept a call that has a passport, that has fields it does not have an understanding of. So arbitrary fields can get added, and the call should still verify. Otherwise, the verification service would not be shaken compliant. So an authentication service could support RCD, and if a verification service doesn't, you won't get RCD, but it will not break the phone call. And the same thing the opposite way around. If the authentication service doesn't put RCD information in, the verification service doesn't need that to verify the phone call, then it can use traditional CNAM or whatever other mechanisms that it wants to display caller display name or anything to that calling party. And of course, out of band shaken is something that's really started to gain a lot of traction. A lot of people are deploying. This is compatible with out of band shaken, as well as it's just added into a passport. It's really compatible with all of the shaken extensions that are being looked at, div, and just anything you can add an RCD to it. Shaken was really designed to be able to support arbitrarily added values into the passport, because you always have a future use case that you didn't think about originally, and you want to be able to support that. So everything is very easy to make backwards compatible. So specifically, let's look at what a identity header might look like with some RCD information in it. So the header's not changed at all, so I didn't display that just to save room. So the payload, these first fields are no different than your normal shaken payload. And that's kind of what really makes this backwards compatible. A verification service can just look for those, find them, verify the call, and continue. But if the verification service supports RCD and it has an RCD claim in it, then you can look at that RCD claim. And within this RCD claim, you've got a couple fields. So the NAM, the name, that's the only required field, and that's the calling party name. This is who's placing the phone call. In this case, it says dentist office. Maybe you want to be more specific, but whatever you put there, you can put. And then you've got an icon. So this is a URL referencing an icon. You can't actually put the icon in this text, but you can put a URL that references it. You've got a URL that references a JCard. You can put either a URL that references a JCard, or you can actually just put the JSON card in the identity header. It is typically fairly large, so most people are probably going to use a JCard URL, but you can actually put it in there directly if you want to. And then it's got the website and INF claim. Again, remains to be seen exactly how that's going to be used, but that's something that may be useful in the future. I'm going to skip this RCDI for a moment. We've also got the CRN. This is fairly recently added, and this is the call reason. This is why you're placing the phone call. And the reason that this is separate from the normal RCD claim is actually pretty simple. The RCD claim is a fairly static value on a per number basis. So it allows a originating service provider to verify some information from an originating service provider level. They need to verify their enterprise who they say they are, and that the information that they supply is in fact the correct information. And then they can store that and say, this is what I'm going to put as the RCD claim every time I get a call from the enterprise using that one phone number. Fairly static mapping of calling number to RCD claim. But the CRN, that's intended to be extremely dynamic, where perhaps it's something that the enterprise sends on a per call basis to the service provider in the SIP signaling that can then get relayed through, so that you can have very specific reasons for individual phone calls. Maybe it's your credit card company and they're calling you, and they have one number that they're calling you from, and they're trying to offer you a lower interest rate. Maybe they say that on the CRN, versus when it's a fraud alert and they think there's some credit card fraud happening, maybe they want to say that. And it may all come from the same calling party number with the same logo and the same website, but you will have a different call reason. So that's why that's kind of done a little bit separately. Now, moving back up to this RCDI claim. That RCDI claim is very important from an integrity standpoint. So what this claim is SHA-256 hash. That's kind of what that SHA-256 prefix tells you, is it's a hash of the remote content, the URLs, not the website, but the icon, the JCard, and JCards can actually reference remote resources like other logos, so even those would have to be kind of all part of this hash. And the reason that that's done is so that when the originating service provider verifies that this logo is in fact the logo of the enterprise, the enterprise can't turn around and change it. You wouldn't want some enterprise to say, here's the logo I'm going to use, and here's the URL you want them to send. You verify, oh yeah, that is their company logo, and then they change it to their competitor or anybody, change it to anybody else and use that to commit fraud. So you can verify not only the URL, but then actually take a hash of that URL at the time you do the verification. And so if it were to change, it would prevent this from being verified any further. So good reason to do that. That being said, I suspect most service providers are actually going to elect to host the resources themselves instead of asking the enterprise for a link to their logo and pointing to that. Service providers should probably ask for the logo itself and host that resource on service provider controlled servers, so that you can get good latency guarantees and availability, and then also, of course, that prevents the enterprise from changing it without your knowledge. But it is important to have an RCDI claim for use cases where you are directly referencing some value supplied from the enterprise. Now, these are all hypothetical, right? Oh, I guess the first one's a standard display, what it looks like today. But these are hypothetical, but we just wanted to show what could be possible with RCD. And I think this is really what makes this so interesting to enterprises. So this is an iPhone mock-up. So you've got an iPhone, you receive a phone call, you get some number here, and maybe it says, on most phones, it says the area that it's calling, the city and state. That's nice, okay, I don't really know if that's spoofed, I don't really know anything. Well, shaken service providers and phone manufacturers could add some green check or some other indicator to say it's been verified. This is not real, this is not what an iPhone does today. Right now, it's actually not on the screen where you receive a phone call, it's only on the screen when you look at your call history. It has a check mark to indicate that it was verified, but not when you receive a call. Once it's more ubiquitously deployed, I think they're going to change that so it's more prominent. But you could have something like this, and okay, I know that that number is not spoofed, but I don't know who that is. When you add RCD to that, now it starts to become really useful. So I know, okay, this is the Home Depot calling, and I've got their logo, so I don't even have to read it. I can just kind of glance at it and see that orange logo that is very obvious from a distance. And I know the reason. In this case, delivery driver is not really a reason exactly, but it's, you know, you could put whatever you want there to just display as it does to kind of provide the reason that this is calling. Oh, this is the delivery driver within Home Depot calling, kind of implies the reason. And then, of course, you've got that verified check mark. And this is something that is really, really powerful for someone like Home Depot. That's why we use them as an example, where on a per phone call basis, it's very important that someone answers. I mean, you order a washer dryer from Home Depot, and the delivery driver is going to call you and say, "Oh, I'm 30 minutes away. You know, come home from work so you deliver it." And you get some call from some random number that you've never heard of. You don't know who it is. You don't answer, and then the delivery driver gets to your house. No one's there, and has to come back and deliver it again. And so that costs Home Depot or anybody, and this is Home Depot as a hypothetical example, can cost a huge amount of money when you have a truck roll behind this. And so adding this RCD information could be immensely valuable for enterprises. And even enterprises that don't have physical truck rolls that are happening. We've heard so many enterprises, this is what is so appealing. Preventing robocalls is great, but adding their logo on outbound calls is what really interests service providers. Now, I'm sure some of you have probably realized this potentially puts a burden on a service provider, right? This is something now that a service provider has to add. I mean, from a technical standpoint, it's fairly easy to implement. Actually, it's quite easy, but you have to make sure that you're not putting bad information in there, incorrect information, intentionally malicious information. You wouldn't want someone to put some inappropriate images and make a bunch of phone calls or anything like that. So you have to validate that that information is really coming from the correct party. And this is really this kind of key concept for service providers, for Shaken in general. Know your customer. And this is something that came out of the financial industry, but it's really starting to hit service providers a lot. You really need to know your customer. And then you need to verify that they supply information that you're going to put in the RCD passport is correct and is accurate to them. And the RCD integrity allows you to do that verification, even if you point to remote resources controlled by the enterprise and prevent them from modifying the resources. Again, it doesn't explicitly prevent them from modifying the resources, but it indicates when it has been modified and prevents it from being utilized. I should say that way instead. And while this is a burden for service providers, I think it's important to remember this is a huge opportunity as well. Enterprises, this is so valuable that this could easily be done as a value-add service. You're not allowed to charge consumers for preventing robocalls. Shaken Trace Act was very clear. You cannot charge consumers to prevent robocalls coming to their handset. But charging enterprises to put their information in RCD is something that everybody is expecting. I mean, there's a huge potential cost, right, to do this verification. So it's absolutely something that we expect service providers are going to do, and can be a real opportunity for additional revenue streams for those, especially the industries that have just an immense value behind those phone calls. Your pharmacy's calling you to pick up the prescription, you don't answer, so they put the pills away, and then they have to re-box it and repackage it when the second time because you didn't come pick it up. That's got some real value to having that person answer the phone call if it's got the pharmacy logo on there. So it's something that we fully expect service providers to charge enterprises for, and we're trying to enable service providers to add this information to their outbound calls. In fact, our Shaken software already does support this, but do it in such a way that they can charge those enterprises for that validation process. In summary,
Alec,
yes.
Quick question, unless you're holding them till the end.
No, yeah, absolutely.
If you go back a couple slides on the Home Depot iPhones, yeah. So you mentioned the Home Depot. If that's sent from the originating side as the calling name value,
yes.
When the call comes into the terminating network, and between the first and second ring cycle, there's a calling name dip. Which one supersedes? Like, what will you use? Will you use the one that's being sent from the originating source, or or the one that you would get from a CNAM, libby database?
Yes. Good question. So TransNexus supplies CNAM service as part of our Shaken service, and I'll tell you exactly how our logic works. Call comes in, we verify the call if it has an identity header, right? Most calls don't have identity headers yet. It's not been widely deployed, but verify the identity header if it's there. If there is RCD information, then we use that as the caller display name that we send to the handset in the PAI, the P-asserted identity header. If there is not an RCD name claim, then we do a CNAM dip. So we actually do not perform a CNAM dip if there is an RCD claim, so we use RCD specifically. And it can save some money on CNAM dipping costs.
Perfect. Thank you.
Yeah, no, that's a good question. Actually, I was on a call with NTTF in Canada last week or the week before, and this is coming up as a big part of this is to make sure that we do things in such a way that can be rolled out in small portions of the network first and not something that everybody has to do. And so RCD is not something that prevents you from doing traditional CNAM dips or enhanced CNAM, more advanced CNAM stuff. You can absolutely do all of that. And I think for the foreseeable future, even if widespread RCD support is deployed, people will continue to populate libby databases so that people who don't support RCD can at least get basic name information. And I think that is something that we expect people to do for the foreseeable future.
That's helpful. Thank you.
Yeah, absolutely. So, in summary, RCD is it's CNAM, just more information. It's kind of like enhanced CNAM, but instead of being something that is fetched by the terminating service provider, it is something that is supplied by the originating service provider, which makes it much more accurate and up to date. So often, someone changes phone numbers or any various different reasons, calling display name information can be incorrect, and that really can make it difficult for handset manufacturers to put this green check. Because if you're not careful and you use traditional CNAM and you put a green check on a phone and you say, okay, this call has been verified, so I'm going to put this green check, but then you do a CNAM dip and you don't know that CNAM information is correct, that green check with the caller display name could easily be construed as being a verified display name to the consumer or the enterprise, the business, whatever it is, whoever's receiving that phone call might incorrectly say, okay, this has been verified as being this party that I think it is. Well, all that's been verified is that the number is correct, and the CNAM information could very well be wrong. So it really allows you to deploy a green check in a much more confident way, because as I kind of mentioned before, most handset manufacturers have not put out a green check when you receive a phone call, and it's likely due to the fact that it is just not yet going to supply the accurate information that people need. And it's stored in the passport. You don't have to go do an external dip, right? That external dip does add latency, and you can cache it. So that external dips don't necessarily have to be that bad, particularly with CNAM. And a lot of times, you will have to go fetch a URL. The good news is those are easy to cache because you typically will use unique URLs. They cache a lot better than a CNAM dip, because you don't have to deal with invalidation of your cache. But it can definitely lower latency, and our customers do see that it lowers their latency in kind of when receiving a phone call. And it's cryptographically secure. The originating service provider put that information in there and signed it, so nobody else changed it. And if they put wrong information, if it was an accident, I think that's going to be something that needs to get corrected. If there's continuous accidents, that's something that the FCC is going to look into. Same with normal shaken, right? You're putting your name on this information, and so other people know that it's probably right, because if it's not right, you put your name on it and you do that too many times, you're not going to be part of the shaken ecosystem anymore. For those who are interested, RCD is all standards driven, right? There's a IPNNI working group in Addis that's developing this for shaken specifically. There's the IETF drafts that are more on the STIR, a little bit more generic, not specific to service fed or shaken. And then there's the RFCs, of course, for J cards and V cards, which is what J cards are built on top of, that kind of supply what information you can put in the different fields, give a little background. So there's a lot of reading you can do here. And of course, our website, we have a lot of blog posts as well as white papers that are linked here at the bottom. One specifically on rich call data that you can read if you want to, not go through quite as long as those RFCs and drafts are. So with that, any other questions about anything?